Assalamu alaikum everyone, I am Mohammad Saad and today I shall be discussing what a DDoS attack is and the different mitigation strategies used to prevent it. So in a nutshell, the DDoS mitigation strategy is basically the architecture that is used to absorb and filter massive floods of traffic so that businesses can stay online. So DDoS is basically distributed denial of service attacks, which is a kind of cyber attack that is common on websites nowadays. So first of all, if we discuss what a DDoS attack is, it is not just about hacking the system, it's more about exhaustion. So if you think of our website as a highway, a volumetric attack will be like thousands of fake cars flooding that highway all at once. So the goal of this attack is simple. It is to make the highway completely unusable for all legitimate traffic. So today, these kind of attacks can actually reach terabits per second, which means that we need proper solutions with massive global scale to fight these type of attacks. So why these type of attacks actually matter, why defending against these attacks actually matter, is the cost associated with them. So firstly, it's not just a technical problem, it's also a business crisis. So if in case of a long time DDoS attack on the website, the website will actually lose a lot of sales and create frustrated customers. So secondly, attacks can actually break the trust. So if customers can't rely on your service, they will move on from your website. And lastly, attackers often use DDoS as a smokescreen. So while everyone is focused on the chaos of the traffic flood, the real criminals might be quietly sneaking in to steal valuable data. So we need to stop the traffic before it ever hits its target. So we have a 4-step mitigation life cycle. So the first step is to detect the attack. The second step is to divert it to a secure facility. The third would be to filter the malicious packets, and lastly, forward only the clean traffic back to the customer. So the first step, detection. This challenge is basically knowing if it's an attack or just a very busy day, like a holiday sale. So our tools rely on two main methods. The first one is signature analysis, which is like having a database of known criminal fingerprints. So if we see an exact match, we can block it. The more advanced version is the anomaly detection. So this is where the system learns the normal traffic patterns of our websites. So if the traffic usually flows at, for example, 1 gigabit per second, and suddenly, let's say, it jumps to 10 or 15 gigabits from brand new unknown locations. So that is an anomaly, and this sudden deviation will actually trigger the defense. So moving on to the second step, which is the traffic diversion. So once an attack is confirmed, we can move the traffic immediately. So we change the internet's GPS to reroute the malicious flood away from the server and to our mitigation cloud. So this is done through two technical concepts. The first one is DNS redirection, which is like changing the website's address on the internet's phone book, and BGP advertisement. BGP or Border Gateway Protocol is essentially how large networks communicate traffic routes. By by changing the BGP route, we tell the entire internet to send this traffic to our scrubbing center and not the original target. Now we discuss the power of Anycast. So this is the core of absorption. When we divert traffic, we don't send it to one big server, we send it to an Anycast network. So imagine the single address of your website being announced from hundreds of locations worldwide. So this splits the massive incoming traffic into hundreds of smaller manageable streams based on where it originates, based on the actual geographical location. The concept is based on dilution, which is we break the flood into drops, and drops are easier to handle than the entire flood. The step 3 is we direct the traffic to our scrubbing centers. So these are specialized facilities where the actual cleanup happens. We call them scrubbing centers. They are high capacity filters designed to tell the difference between a real customer and a malicious bot. So the filtering logic that can be implemented is the deep packet inspection, which is like opening the envelope of every piece of mail to see if the contents are malicious, not just checking the center's address. So we can look through the code and check if it's generated by a bot or a human. Next is rate limiting, which is very simple. We cap how many requests one source can make per second. It is, for example, the one item per customer rule. The third one is the challenge response. This involves using quick tests often invisible to humans, like JavaScript challenges, to prove the user is not a simple automated script or a bot. Lastly, we can implement IP reputation, which is to maintain global lists of known bad actors server, compromised devices, or bad IPs. So if traffic comes from this blacklisted source, we can block it immediately. The last step is forwarding. So once the traffic is perfectly clean, we can send it back to our original server. So crucially, we use GRE tunnels or direct connects. So we can think of GRE tunnels as secure private bridges. It encapsulates the clean data and delivers it privately, preventing the attacker from finding the real target again. So the clean traffic arrives safely and the service remains up. We can also implement real-time monitoring strategies. Because attacks can start in seconds, human reaction time is often too slow. So automation is critical. The system has to detect and deploy defenses instantly, but we do not rely only on the machines. We can also implement a 24/7 network operations center, which is staffed by human experts who manage the most complex application layer attacks that might try to sneak past the automatic filters. It is also better to always have post-attack reporting mechanisms. So when the attack ends, the job isn't finished. We can also generate detailed reports or forensics to, to understand the attacker's methods and origin. So this data is essential for two reasons. Firstly, to meet regulatory compliance, and secondly, to constantly tune and optimize our defensive policies for the next time. So we can implement this using two methods. The first one is the always on, which means that traffic is permanently routed through our scrubbing centers, offering 0-second defense but adding a tiny bit of latency. The second is on demand, which is cheaper and faster in peacetime but requires a few seconds to reroute traffic when an attack begins. So the choice of whether to use which deployment strategy depends on the criticality of our service. So lastly, to summarize, it is the DDoS mitigation strategy is a global multi-layered defense. We fight distribution with distribution. We don't just hope the traffic stops. We absorb it, filter it, and deliver a clean pipeline to ensure our business remains resilient. So that would be it for my presentation. It would be appreciated if you guys can paste the comments, paste your questions as comments under the video. And thank you. That would be it from my side.